So here we're going to continue on the lesson 2, and here we're going to speak about hybridization, hybrid orbitals, hybrid orbitals. So what is hybridization? Okay, so we spoke already about orbitals. We spoke about the atom, how the atom is working. We spoke that we can't follow the electrons, etc. Now we want to try to explain all the boundings in the molecules with our theory, the theory, quantum mechanics theory. So when we see, for example, CH4, we're going to take some examples. We want to understand what are the bounding in the CH4. Example, we want to understand the bounding in CH4. In CH4, it is like that. H here, H here, H and H. This is, if you do the Lewis diagram, you will find these ones. The experiment shows us that the four boundings are equal. The four boundings, the four CH are the same. There is no difference. Good. This is experience. This is what the experience tells us. Experience. So now we're going to go to the theory. What the theory is telling us. So what quantum mechanics is telling us. What is telling us? So theory. The theory is telling us, if you want to understand orbitals, go for the carbon. For the carbon, for example, what is the configuration, electronic configuration for the carbon? The carbon has 6 electrons. I'm going to put it here. 6 electrons. And its configuration, it is 1s2, 2s2, 2p1, 2p2. This is its configuration. What are its energy levels? The energy levels also are easy to find because you know how to do them. Now I have 1s, I will have 1 up, 1 down. On 2s, I will have 1 up, 1 down. And on 2p, I will have 3 orbitals, but only 2. 1 here, 1 and 1 here. So what the theory is telling me, your carbon can do only 2 boundings. Why? Because I have only 2 orbitals, half empty. Because to do boundings, you have to have an electron in the bounding, in the orbital. Why? Because, for example, if I see H with carbon, what the hydrogen is bringing an electron. The carbon is bringing an electron, and then they share them. This is the covalent bounding, and this is the theory. So which one have electrons? Only 2 here. But the experience is telling us no, the carbon can make 4 bindings. But here the theory is telling us there are only 2. So the chemists and physicists say, wait a minute. This situation here, or the configuration here, it is what we call ground state. It is the ground state. When the carbon is not looking for binding, it is what we call ground state. It is the ground state. When the carbon is not looking for binding, it is not preparing to make binding, to make linkage with, to make binding with another atoms. It's like you, for example. You are at home, you're not expecting anybody, so you feel free. Okay, you do what you want in your house. But if you are expecting somebody come in, or you are inviting somebody to come, then I'm sure that you're going to prepare your home. You don't want them to see a lot of things, and you want them to see some things. So there is preparation. And this is what the physicist said. The physicist said, when the electrons or when the carbon is prepared to make boundings, it will prepare itself. And it will change the ground state to another state. So what the carbon will do, it will do hybridization. So I'm going to write it here. Orbital hybridization. Orbital hybridization. It will prepare itself. Hybridization. This is what it will do. How it will do it? It will do what you say. First, I'm going to go from my ground state. This is the carbon. My ground state, I have 1s. one up, one down. I have 2s up and down, and I have 2p. I have only in these two rooms, three rooms, I have only 2. He will do what we call a promotion. What he will do, we say, okay, 1s, it is basement. It is too low. There is nothing to do. I am inviting 4 people because I am the carbon. I can do 4 binding, so I can hold 4. But I have only 2 who are ready, who are single, that are ready to bind. So how I'm going to do? I'm going to promote these 2s here. I'm going to split them and going to promote them. So this is what we call promotion. Electron promotion. Electron promotion. What we call it? Electron promotion. Because the carbon has an empty orbital, so he will make promotion. What promotion will do? Yeah, 1s will not touch it. It is the basement. It's like the basement, so we can put nobody there. The 2s here, and I have 2p. One of the 2s's will stay. I have the 2p's here, and the other 2s will go here. So what we are going to do, like a room here, we're going to empty a room with 1, and we're going to tell to somebody here, go to this room here. And now we have 4 here. But these 4 are not equal, because I have orbital in type S, and I have orbitals in type P. Okay, so they are not the same. So what will be next? It is mixing. That's what we call it, hybridization. So this is ground state. So the ground state, it is when the atom, in this case the carbon, is not expecting anything. It is there at home, the carbon state, the ground state. And this one, it is an intermediary. So what will do the carbon here? It will take this situation here and it will hybridize. So I'm going to write it here, hybridization, orbital hybridization. So it will take the 1s, we said this one, it is the basement, nothing will happen. The 2s, now we have only 1 electron. The 2p, we have here 3, and we have the 3 electrons here, and we have 1 that it was promoted. And then now what the carbon will do? It will hybridize. Orbital hybridization. A hybrid. What is a hybrid? It is a mix. For example, we call a hybrid car. What is a hybrid car? Hybrid car, it is a mix with electrical and gas. Yeah, that's what's a hybrid. So it will mix 2 things together. Hybridization. And it will mix this orbital with this 4 here. And what we will have? The first state, 1s, it will not change. This is the basement. Nobody will go there. And what we will have 4. The same. I will have 1 electron here, 1 electron here, 1 electron here, 1 electron here. All these 4 electrons now are ready to receive a gas. And this one, we call them sp3 hybrid orbitals. sp3 hybrid orbitals. sp3 hybrid orbitals. Why we call them sp3? Because we mixed 1s with 3 p's. The mixing here, what we mixed? 1s, 1 orbital s plus 3 p orbitals. That we call it sp3. The one here, like mathematics, it is 1s, 3p. This one here, like mathematics, it is useless. That's what we call these 3 orbitals. We have now 4 orbitals, 4 sp3 orbitals. And now we can explain why the carbon can make 4 bonding with the hydrogens, because it prepares itself to bound in, and does it. We have the situation. Now the carbon is ready for 4 equivalent bonding with hydrogens. For example, bondings with hydrogen, for example, it can be anything with hydrogens, for example. And this is why CH4 exists, and CH4 is very stable. It is one of the main components of natural gas that we use to burn. We're going to take another example now. For example, hybridization in boron. Now I'm going to take another example. Hybridization. We saw the hybridization in carbon. Here we're going to say hybridization. Hybridization in boron. And we're going to study also the boron. The boron, how many electrons has the boron? It has 5 electrons. So what is its configuration, electronic configuration? It is 1s, 2s2. But I'm going to write them configuration. 1s2, 2s2, 2p1. This is the boron. If we do its energy levels diagram, it has 1s2, 2 here, 2s2 here, 1 up, 1 down, and 2p1. We don't write when we do the grams, we don't write the numbers here. Sorry. And what we have here, we have the p's, and we have only 1. So what the boron can do? The boron will to react because he wants to be stable, and he see himself. He say, what I can do now? What I can do? I can prepare myself for reactions. I can't use 1s. 1s is too low. It is the basement. Nobody will go to the basement. But I have the second floor. Second floor to S to P. What I can do? Promotion. First promote. Promote at least 1 electron. Promotion. Promotion. Electron promotion. I'm going to write here electron promotion because I want to respect that. I'm going to say promotion. Electron promotion. So when I promote, what it will give me? 1s. This one, as we said, we can do nothing for because it is too low. We'll have 2s. We have to leave 1 electron there. You can't empty one orbital. You can't, because 1 orbital you can't empty it. We have 2p. We have the 3 here. Before we have 1 electron. Now we will have another one, the one that we promoted. And now the boron, what he can do? Yeah, he can hybridize. He can mix. Which ones he can mix? He can mix the S and the P's. But how many P's? He can mix only 2. He can't mix this one because there is nobody here. Because to make a bonding, you need an electron. This orbital to bond with another one, you need an electron on it. If there is no electron in it, you can't bond it. So what's the boron will do? He will say, for now, I'm going to hybridize what I can. So, and I see how many guests I can have. So hybridization, you will say, now I have 1s. As we said, nothing can be done here. This orbital here, it is in the ground state. We have 2s with 1 electron. We have 2p. We have 1, 2, 3. I have 1 electron here, and I have the one that I promoted. Now we will say, I'm going to go to hybridize. Orbital hybridization. Go to it below. Orbital hybridization. Hybridization. And what he will hybridize, which ones he will mix? He will mix this S with this 2P. So he will end up with what? He will end up with this one. 1s. There is no s, but he will have 3 here, and he will have 1 here. The one that it is empty, it will stay empty. So he will have 1 electron here, 1 electron here, and 1 electron here. These 3 here, they will mix, and you will have here what we call this one's sp2. And this one, it is a p. It will stay p. It will stay a 2p. I have 1 orbital 2p, and I have 3 sp2. Why we call it sp2? sp2 because we mix it 1s with 2 p's. Mix in, why sp2? sp2 because we mixed what? 1s with plus 2 p's. That's what it is called, sp2. The one here, it is useless. And we have 2p. So boron, how many bonding he can do? 3. He can do 3. So for example, if he finds hydrogens, what he will form? He will form BH3. For example, I have 1 hydrogen here. He will bond with this one will bond with this one. But BH3, it is unstable. Very unstable. Very unstable. But this is the theory, what it's telling us. Telling us boron, naturally, what he can do? Only BH3. Now he has an empty orbital. So what he can do? So what he can do? He can see somebody who has 2 electrons, and he wants to go and rent this room. And it happened. For example, if we take BH3 plus H minus, it will give us BH4 minus. What is H minus? H minus, it is an hydrogen that gains an electron, because hydrogen has only 1 electron, but if it is minus, that means he gains another electron. If he gains another electron, he can put these 2 electrons. I'm going to put them here. He gained these 2 electrons. So this now it is this one, it is minus because he gained it. These electrons will go here to form for us BH4 minus. So this is what, and BH4 minus, it is more stable than BH3. BH3, it is very unstable because it has an empty orbital, okay, vacation. You want to rent it. So what he will do, can react, for example, with H minus to occupy. So the H minus will bring the 2 electrons with it, and it will go there. So this is hybridization. Hybridization, it is only a way to explain some boundings. That's it. Okay, bye.